Hi guys, we are back and we are doing what the textbook calls substitution. I call it K method. So what we're having here is now we have to try to solve a problem like that. It does look horrible. One would think about multiplying the whole entire thing, multiply the whole entire thing by a denominator, which is x squared minus 2x. Oh, that's going to be too much. You're going to run with powers that are about x to the power 4, which is quite hectic. I don't know, what else can you do? Okay, you have a fraction there and you're dividing stuff by a fraction, so you don't want the denominator to be 0. So at the moment, what you could really do is to make sure you write your restrictions. Remember, your restrictions are very, very important, because if that denominator happens to be 0, you can't solve that expression, or equation rather. I'm sorry guys, not an expression, it's an equation. You can't solve it. So what do you need to do? You need to tell me what are your restrictions. How do you find that? You say x squared minus 2x, you set the whole entire thing to 0, right? You're going to find that your values of x for which that would be 0 would be when x is equal to 0 and when x is equal to 2. So you're therefore saying that in that expression, x may not be equal to 0 and x may not be equal to 2. Now what do? I refer to this as a K substitution. So basically, where there is a repeated expression. So if I look at that term, and I don't want to call it where there is a repeated expression, there's a repeated expression here, which is this, it's here and it's there. You want to say, let that be equal to K, right? So you can see we're saying, let that be equal to K. Let that be equal to K. If you equate that to K, this is what you get, right? You put K over here, you put K over here, that's what you get. Now you're going to solve for a value of K. After solving for the value of K, you then going to say, okay, now I have the value of K, but that's not what I was solving for. I was solving for the value of X, right? I was solving for the value of X. So over there, you still have to mention another restriction, because K cannot be 0 there. You'll have a problem if K is 0. So you'll say K cannot be equal to 0, and you have that. You have to multiply all of it by K, because K is in there, is in the denominator, right? So you multiply throughout by K, you're going to have that. By now, you have 3 methods to solve that. Factors, completing a square, quadratic equations. And then you can find the value of K. So here we've used factors. And then you have to check your K must not be 0, right? Because you said K may not be 0. And you can see K is not 0, so that's fine. And then you must come back and say, remember, you are not solving for K, you are solving for X. So you need to come back and say, now I've got my K is whatever value. What is my corresponding X value? So you're saying K is minus 1. That's where you put your K, and then you solve for X. That's what X turns out to be. And then again, you have K over there. You then put it there and you solve for X. Now guys, and then you can check if your X is not equal to any of the restrictions that you had, which was minus, let me just go back and check. It was a restriction. It was 2, x may not be equal to 2 and x may not be equal to 0. And from all your values of x, you don't have that situation. So you are happy. But guys, so that's your values of x. I wanna draw your attention to something else, right? So let's look at this. I said, if you were to multiply throughout by that, what you were going to have, you're going to have your highest power being x to the power 4. Now guys, if your x is to the power 4, it means that you expect 4 answers, right? You have 4x values you expect 4x values, right? Yeah, 4x values. And that's really what you get here, because you have your first x, But remember, this is x minus 1, this is x minus 1, so really there's two roots there. It's just that that's a repeated root. And you have these two ones, so you really have 4. And that's really, it's that simple. I'll just go through some problems and sort of like show you how the method is not going to change. So what do you look out for? You look out for your repeated root, right? You look for your repeated root. No, not repeated root. I'm so sorry. Repeated expression. You look for your repeated expression. X squared plus 5x is a repeated expression here. That's what you let equal to k. If you take this 18 to the other side, you have x squared plus x and x squared plus x in the denominator over there. That would be your repeated root. This would be your repeated root over here, and so on and so on. Over here, you're also going to have a repeated root. You would have to multiply that out to see that you would have a repeated root. But guys, it's not going to be that simple, right? So you are going to find x substitutions that are a bit different from what's happening here. They are a bit obvious, but you would have to exercise the same idea. So yeah, that's it about what they call substitution. I call it K method. So all the best. We'll move on to the following section after this video. Bye guys.